My name is Jurgen Pabel. Um, During an earlier talk, there was mention about that there aren't really that many solutions for, like, actually protecting data, or that, well, no, that's not true. That protecting data stuff isn't, doesn't receive that much attention, and I would like to get your attention on something that can help protect data for now. It's about protecting HTTP session data. So you have some web server, some application, internet, you've hardened the system, etc., audit the application, users connect to the web server, the application logic takes here, whatever data is persisted goes in here, and session date is usually stored in another database like memcache, whatever technology you choose to employ. And this talk is about protecting this data down here. Not the persistent data in the database, but the session data. So what you have is web application use cookies to maintain state. So you have maybe like for PHP, like a PHP session ID, and this ID is sent with every request. So when the user is logged in, based on this session ID, the server knows which user it is. So, okay, so this picture is supposed to show on the left-hand side that you have several web clients, browsers, each has their own session. The session ID gets transported to the web server gives it to the application server looks in its session database, looks up by some key value, so session ID A looks up in the key column, finds the right session ID, and finds the session data. So here, for session A, user Jurgen. The problem with this is that someone who has access to this session database, they can just A, take the session IDs here, copy them into their own browser, and they're logged in as that user. B, they can extract this data, which might be stuff that you would want to be protected from whoever has access to this system. So assuming for this scenario, you have maybe like a database admin who administers this database but has no access to the web server or the application server itself. So what SSDS, Secure Session Data Storage, is for one, it provides for a mechanism to secure the session ID. So whenever the client sends the session ID, the module hashes it, a storage ID is derived, and the storage ID is then used as the key, like the key in the database. So someone who can access this database, all they see is the hash of the session ID. They can no longer take the session ID out of the database, copy it in their browser. So essentially, they cannot impersonate a user. They can still access this data in this configuration. So there's another option implemented or perceived, which is encryption of this data. So essentially, the session ID is hashed. That is then the encryption key. The data stored in the storage database is then encrypted using this key. The encryption key itself is hashed again, and that is the hash that's used for looking up the data in the storage database. So there are a couple issues. Like, one is encryption. You have one key that's constant for the session, but you have multiple data states. You might have a data state user not logging, user logged in, user submitted a credit card information. So all this is different data that needs to be encrypted using the same key. And cryptographically, you need to, for encryption things like this, you need to provide an initialization vector that makes each encryption run for each state change unique. So what you can do is you can just generate this initialization vector randomly. Of course, then the server at some point will have problems with generating random numbers. The entropy pool is probably going to be empty real quick. So what this concept does is it takes the session ID, concatenates the current timestamp, and then hashes that. And that's an unpredictable and unique initialization vector that's then used for encryption. So what I implemented so far is a PHP extension. PHP for saving all this cookie data or the session data. You have what's called a safe handler. And so what you do to activate this in PHP, if you have the module, is say SSDS is the safe handler implemented in this module. And then you need to tell SSDS where to save the data to. So like maybe a memcache, maybe file system, whatever. And then you have configure options down here that actually control the mode and the algorithms that are used by the module. So the hashing algorithm that makes it from a session ID to a storage ID is this one. This is the encryption algorithm. This is the hash that derives from the session ID encryption key if you use it. And then you have another algorithm down here for derivating the initialization vector. So I don't think there's a time for demo, but what it does is essentially, if you look at it, a simple application, PHP application, with this session ID and the storage backend being the file system, then you have, for example, a file var lib php and then sesh underscore and the exact session ID. So this could be taken and used to be impersonate a user. And this is actually the content of the session. So you have a variable time, which is type integer, has this value. You have a second value, data, type string, length 1, value x. So you see this ID of the session and you see the session itself, the data itself. Then after activating the module, this is the hashed session ID, no longer of use for anyone except for the browser itself, the user of the application. And this right here is the encrypted session data. So the encrypted session data goes down to this equation sign, so it's base 64 encoded. The hash mark separates the encrypted data from the initialization vector that needs to be employed when decrypting the data. And every time the data changes, this file gets rewritten. So every time this value changes and this value, the initialization vector changes. PHP SSDS is stable, audited, no security flaws are found. Java SSDS for Tomcat is work in progress, early work in progress. And if anyone wants to implement it for any other technology, just come talk to me. I'm done.